Hey everyone, welcome to the channel. So what are we going to do today? Today we are going to write a Solana smart contract, a very basic one, and understand how Solana really works. So we need to install certain tools for that to happen. The first thing you need is the WSL. Look up any tutorial online, there are a lot of them, and which will easily help you set up WSL in your local system if you are on Windows. Now, first we need to install a certain tools. The first thing you need is Node.js. Install the LTS version. The next thing you need is the Solana tool suite. For that, go to this particular link. All these links will be down in the description, and run this command in your WSL terminal. Then you need the Rust programming language, and for that, go into the Rust book and go into this installation page here and follow along. Rust is the programming language which we will use to write our Solana smart contracts. Then the last thing I need you to install is the Anchor Lang. Anchor Lang is a framework which is written on top of Rust, which makes the process of writing Solana smart contracts easier, much easier. So go into installation and follow along this tutorial. The only thing you need to run is this cargo install command. Then you need to run these commands. So after you have installed all of this, come back to a folder and open your Linux terminal. Now, first to check that Solana is correctly installed in your system, run Solana test validator. What this will do is this will create a local ledger and start and initialize a local blockchain in your system, with you being the only node in it. So you see the local blockchain is running in my system, and yep, Solana tool suite has been successfully installed in my machine. So I'll cross out of it here. And the first thing we need to do is initialize a project. So we'll hit anchor init. Let's just name it Noter because we are going to create a note taking application, and hit it. Now this will take some time, and I'll see you when this is done. Okay, so that initialized our project. I will cd into my Noter folder, and I'll open this with VS Code. So now let's just see what all is present in our project. Okay, so a lot of it is here, but there's only going to be a few things we'll need. The first thing is this anchor.toml file. This file has the ID which identifies our program. Then it has the provider under which we will write the cluster. We can write three types of cluster: the local net, four types, my bad: local net, test net, dev net, and mainnet beta. Then comes the wallet. This wallet is actually a key pair which will sign off all the transactions we will write in our tests. And the last thing is a script. This is the command which will run when we run anchor test. Now, the next thing we would want to see is inside the programs folder, there's a Noter folder, and inside that there's cargo.toml, and there's an Asasi folder under which there's lib.rs. So under cargo.toml, we will find information about our Noter program. So there's information about the package, and there are information about dependencies. The only dependency we need right now is anchor lang, and that's of version 0.24.2. Now make sure that this version is less than 0.24.2. The reason is security vulnerability was recently discovered in Anchor, and it was fixed in version 0.24.0. So if you try to use any version less than 0.24.0, it will not work because cargo.toml will not recognize it. So it's best to use the latest version. And then comes lib.rs. Lib.rs is our actual contract. This is here we will write all our programs and functions and everything. which will actually go up in the blockchain. And another last thing we need is this. Under this tests folder, there's a nota.ts file. In here, we will write all the tests for our program. Now, testing is very important, and you should always write tests for your program. Now, let's go back to lib.rs. And what I want you to do before starting coding is go back to your WSL terminal and hit anchor build. This will build our program. So this will take some time and wait for it. Okay, so our program has finished building and it just throws us an error, but we are just going to ignore it for now. Now let's talk about how Solana functions. As a developer, you need to remember that everything in Solana is an account. The note we will create is an account. The wallet which will sign the transaction to create the note is an account. The sol tokens which will be used to sign the program, which will be used as gas, those sol is also stored in an account which is associated with the user. So everything in Solana is an account. Now what we need to do is we need to define the account which will store all the user nodes. For that, we will start by writing the account attribute. So we'll write a structure. So pub struct, let's name it node. The first thing we want to store is the content of the node, and the content will be of type string. The next thing we want to store is the user, and the user will be the person who owns the node. So user, this will be of type public key. Save it. Now let's come back to this particular function, this particular program. What is it doing? Now see this particular anchor use anchor lang prelude statement. This is just importing the anchor lang module. After that, we have a declare ID line. What is this doing? This is denoting the unique ID of our program, which will be used to identify our program. Now, when we hit anchor in it, this particular string was generated by anchor. This particular ID, this MG61, this is a template ID. This is not your unique ID. So how will you find this unique ID? What I want you to do is go to your WSL terminal and write Solana address, give the K flag, and inside the quote, you need to give the path to the key pair which denotes our ID. Now, this key pair was generated when you ran anchor build, and this is stored inside target deploy nota keypair.json. See this key pair? This key pair is the one which can be used to uniquely identify our program. Hope that makes sense. So inside here, we'll write target slash deploy nota keypair dot json and hit enter. Now this particular public key that you see, this particular ID, this is the ID which can be used to uniquely identify our program. So paste it and hit save. You also need to update this particular ID in anchor.toggle. So see here inside programs.localnet how Notar is using the template ID. Just swap it out and save it. Now back in lib.rs, we see a program attribute in here. What does this program do? This program is basically the entry point of our contract. Inside here, we will write all the endpoint functions which can be called from a front end into the blockchain. And each of these functions will be using a context. This context will be a structure which will hold all the accounts that needed to be passed for this function to work. That was a bit complex. Now, let me just show you how this happens. Now, we want this function to be create note and this context to be create note. Now, inside this create note, so info, inside this create note, we need to pass in the accounts which will be used by our create note function. So the first account we need to pass is the note account, the note which will be saved into the blockchain. And the second account we need to pass is the user who will own this particular account. Now we'll write hash account, and this account will be called note. This will be an account for of type note. Hope the syntax is clear. Now inside this account we need to specify what can be done with this note. So it will initialize. Okay, the user who will pay for this node to initialize is a user, and we need to specify the pair because storing information in the blockchain is not free. It requires you to pay some sol so that the blockchain can store your data, and we need to specify the space. The space is the amount of space which needs to be allocated for this node, and we can do with 2000 bytes. That would be enough. Now the next thing we need to pass is the user. So hash account mutable. This will be user, and this will be a signer account because this user will sign this particular instruction. And you see an error here. This is because we are trying to initialize a particular account, and whenever we try to initialize an account, we need to ask the system program to do it. So we need to pass the system program here. Pub system program. This will be a program of type system. Okay, so we essentially have written our create node account struct. Now this account struct will be used by our create node function. So let's see how we can do that. First, we will get a mutable reference of our node. For that, we'll write let node equals and mute context dot the accounts that we are passing. Inside that, take the node. Why do we need to pass a mutable reference? That's because we will be changing information on the blockchain. That's why we need to pass the mutable reference. And we also need to give the signer. So user will be context dot accounts dot user. Now, what do we need to do? We need to save the content and the user of the node inside the blockchain. For that, we need to pass in a second argument into the create node function, which will be the content, and it will be of type string. Now, the content of the node which will saved into the blockchain will be the content which we passed inside through the function into the function, and the user of the node will be the key, the public key of the user we passed. And that's it. That's essentially the function we need to call from our front end to create a node. So let's build the function. Anchor build. That does it. Now we need to write a test to make sure that our users can actually create nodes. For that, let's go to node.ts, and you can already see an error here because we removed the initialize function. So for that, we just remove this test completely. And what we need to do first is we will need this anchor.anchorprovider.env thing. So what we could do is we could store this in a provider constant and call that provider into anchor.setProvider because we will be using this provider later on. just a small thing I wanted to point out. So let's start writing the test. It can create a node, then pass an async callback function. First, what we want to do is we want to create the key pair of the node we are going to pass. So const node, no, not const, my bad. Let node equals anchor dot web3 dot keypair dot generate. Save it. Now what we need to do is we need to create, or rather we need to call our create node function which we wrote inside our lib.rs file. So await program.rpc.create node. RPC is deprecated, but you can use that for now unless a better alternative comes up. So yeah, use RPC. The first argument we need to pass is the content of the node. So content of new node, and then we need to pass in the accounts. Now, one thing I'd like to point out is, see here we wrote create node function here in camel case, but we are calling the create node function, sorry, in snake case here, and we are calling the function here in camel case. Now, that's because Anchor allows us to follow the convention of the respective languages. So since snake case is the convention of lib.rs, we can use snake case here, but since camel case is the convention of TypeScript, we can use camel case in here. So inside the accounts, the first thing we need to pass is the note, which will be the note.public key. Then we need to pass in the user, which will be the provider.wallet.public key. And the last thing we need to pass is system program. The system program will be anchor.web3.keypair. Oops, not sorry. Anchor.web3.systemprogram.program ID. And we also need to pass in the signers. So these signers are the ones which will sign this particular instruction. So the signers array, it will be an array, and we need to pass in the note. We also need to pass in the user who is signing this particular instruction, in our case provider.wallet.public key. But inside this test, we do not need to pass this particular wallet because it is stored inside the provider, and Anchor automatically passes that particular provider wallet as a signer. So we do not need to mention the provider wallet explicitly inside the signers array. Hopefully that makes sense. So now what we need to do is we need to make sure that the node was indeed created. So what we need to do is let new node equals await program.account.node.fetch, and we'll fetch the node which has the public key of the node. Now don't confuse this node with this node. This node is basically this particular node which we are passing inside fetch is basically the key pair we just created. We created a key pair and we passed that the public key of that key pair as a node. So what happened was a particular node was created having the public key of this key pair. So now what we are doing is we are trying to find the node which has this particular public key. Hope that makes sense. Now we need to assert that this node was indeed created. So assert dot strict equal new node dot content is this particular string, and we also need to assert that new node dot user is the same as provider.wallet.public key. Now this test will fail, and I'll tell you the reason once we have actually run the test. So let's clear the terminal first, and we'll write anchor test. Okay, so the test failed as expected. And what is this error? It's saying assertion expected public key to equal public key, which means, and you can see that this is in nota.ts line 28. So in line 28, we have assert.strict equal new node.user and provider.wallet.public key. These are equal, but this user and this public key are both in the form of a big number, and TypeScript cannot understand big numbers. So what we need to do is we need to decode it to base 58 format, both of them. Save it, and now if we run the test again, the test passes. Okay, that's great. So now we are sure that users can come in and create a note. But what if users want to delete a note? So for that, we will create a new endpoint and a new account struct. Let's start with the account struct. So hash derive accounts pub struct. Let's name it delete note. Now the first account we need to pass is the note we want to delete, and the second account we need to pass is the user who owns the note. So account, it should be mutable. It has a user and it will be closed by the user. Write a note. It will be an account info of type note. And the second thing we need to pass is an account. It should be mutable and be a user, and the user will be signer. Now, what just happened? So we are passing in the note as an account. The note will be mutable. What does this has one equals user signify? This signifies that this particular note account will have a user field, and this user will be same, the public key of this user will be same as the public key of this user. That's basically it. And this particular line close equals user, this signifies that this particular account will be closed by the user. Closing essentially means deleting. So that was our account struct. Let's just write our function now. So function delete note. It will be context delete note, and it will return a result. So in here we just need to write OK, and since we are not using the context should trail by an underscore. This underscore will just notify our function that we are not going to use the context, but we are going to pass it in our function. Save it. Now, why aren't we writing any piece of code, or why do we not need to write any piece of code inside our delete note function? That is because we are specifying here in this particular constraint only that this particular note account will be closed by our user, and hence we don't need to write anything in our delete note function. How neat is that? Now let's just make sure that the users can indeed delete a note account. So it can delete a note. async. Here we want to call the delete note function. Before that, we need to build our lib.rs file, because unless we do that, the TypeScript test file won't recognize this RPC call. So anchor build. Okay, so that's done. Go into our test file, and inside the async function, we want to call, we may want to make an RPC call to our delete node function. And it doesn't take any argument other than accounts. So we pass in the accounts. And inside that, we need to pass in two accounts. The first one is the node, which will be node.public key. And the second one will be user, which will be provider.wallet.public key. Now that's our RPC call done. Now we want to make sure that this instruction did really go through. So let deleted node equals await program.account.node.fetch, and we no, not fetch, this should be fetch nullable, because we are trying to make sure that we cannot fetch this particular node. So we need to pass in the node.public key, and we need to assert that this deleted node is indeed null. So open the WSL terminal and write test. Oops, our test failed. Why is that? Why is, oh, sorry, my bad. This not be, this will be equals null. So we'll run this again. Yep, that's it. Our tests pass. And congratulations, guys. You now know how to create a very basic smart contract for the Solana blockchain. So thank you all for watching this video. Let me know down in the comment section if you want me to create a front end of this particular contract, or if you want me to make it more complex and resemble a real note-taking application. Let me know all that down in the comment section. Thank you guys for watching this video. If you enjoyed it, don't forget to hit the like button, subscribe, and I'll see you all in the next one. Bye guys.